Yeah, I need to say that today's problems are very nice. I hope you enjoy it as much as I did. I looked through the problems and they are very nice, very pretty problems. Okay, so the very first question says there are 100 soldiers in a detachment, and every evening, 3 of them are on duty. Can it happen that after a certain period of time, some soldier has shared duty with every other soldier exactly once? Let's understand the question. Can it happen that after a certain period of time, some soldier has shared duty with every soldier at least once? So let's just um, record the information. So each day, every evening, there are 3 of them. So there are 3 people. There will be, let's put 2 guys here. And you want to know whether there is, okay, there are 3 people, but I'm going to just put down various, in each day what happens. Okay, and in each day you got 2 new people. So the question is there any person who's shared the detachment I wonder why the color is not coming. Okay, I'm having a problem with the colors. All right. I thought I'll use some other color for this, but it's not coming right. Okay, so there is one person, let's put a circle for him, who is in the guard duty every day. So the question is it possible that there is a single person? Can it happen that after a certain period of time, some soldier, we are using this round circle for a soldier, will share duty with every other soldier? So these 2 people are different, right? Exactly once. So if that is possible, so it means now that you've got the number of people would then be 2 plus 2 plus 2 plus 2 and so on. And this person here, you only count him once. The guy was repeated. So the number of, if so, that means if there is such a person, then the number of people in the detachment sorry, the writing is so bad, is you got a multiple of 2 because 2 plus 2 plus 2 plus 2 plus 1. Namely, the same person who is sharing this all the time. So, but this is an odd number. Which is an odd number. But you got 100 soldiers, you see, right? And that cannot be equal to 100. So it's impossible. Because if it is so, then you get a contradiction. You get something which is impossible. So the assumption, this assumption is false. It means it is not possible. See? Right. So very often you solve a problem by making the assumption. They ask you to prove something and you say, well, suppose it's not true. And then you come to a false conclusion. And you'll say, well, why did I get a false conclusion? And then you will conclude that your original statement is false because you started off by making an assumption. Like I made an assumption. If it is so, that's an assumption. Then you get a contradiction. Therefore, it is not so. That is false. So the thing is impossible. Okay, it's a very important type of an argument, this is. Right? They call this a proof by contradiction. Okay, so let's just get on to the next one. Now, here, so that m and n are both odd integers, then which of the following numbers must be even? Okay, let me just talk about this a bit. All right, now, there are some things we have to know about odd numbers and even numbers. In the first case, if you add two even numbers, I'll put E plus E. If you add two even numbers, your result will be an even number, right? 4 plus 8 is 12, which is even, 10 plus 25, 10 plus 26, 36, and so on. So an even number plus an even number is an even number. Now, this is not a symbol. I'm using the symbol E, even number, plus an odd number will always be odd, right? 7 plus 8, that's 15. It's going to be odd, always, right? The reason for that is an odd number plus an odd number is always 1 plus an even number, isn't it? An odd number is 1 more than an even number. So then it's 1 plus an even plus an even. But we already saw that even plus even is even. So your final answer is 1 more than an even number. So that must be odd. So that is why you have even plus odd is odd. Likewise, odd plus odd, an odd plus odd must be even. Why? Because this is 1 more than an even number. This is 1 more than an even number. So this is, if you add those two things, you got 2 plus an even number plus an even number. And 2 plus an even number is even. So this takes care of the addition. Now, likewise, an even number multiplied by an even number is even. An even number multiplied by an odd number. Now, this you must be careful. Is always even, right? Because an even number multiplied by an odd number, this is 2 times something. We don't care what it is. 2 times something, an even number, times an odd number. But 2 times anything must be an even number. See? Doesn't really matter what it is. As long as it's multiplied by 2, it must be even. And then you have finally an odd times odd is always odd. Right? 3 times 5 is 15. It can't be even. Okay, because when you factorize this, there are no 2's in this and there are no 2's in that. So the product, you can't have a 2 in that factor. Okay, so those facts you have to know. It's not very difficult, but it's important to know. Okay, the sum. So the sum of two numbers is always odd. This is the way I think of it. Is odd only if the two numbers have opposite parity. have same. I just want to use the language here. Parity. The parity of a number is its evenness or oddness, right? Let me explain. Like if you can talk about two numbers having the same parity. It means that they are both even or they're both odd, right? If they got the same parity. But if they got an opposite parity, then one of them is even and one of them is odd. So the way to remember this is that if two numbers have opposite parity, then their sum is odd. Otherwise, if they got the same parity, like here, the sum is even. And here too. But here, of course, it's different. They have, if both are odd, it's always even, except in the case where both numbers are odd. So just remember that. The product of two numbers is always even, except in the case where both are odd. It's only exception. Okay, now bearing all that in mind, M and N are both odd. All right. So here you got odd times odd. So this is odd. That's what odd. Now here, both of M and N are odd. So you have odd times odd times odd, right? And odd times odd is odd already. And again, you multiply on odd, you're going to get odd plus 2. Now, an odd plus 2 is still odd. If you take an odd number, if you add 2 to it, if you add 1 to it, it's even. If you add 2 to it, it comes back to being odd. And here you got an odd plus odd. These two things together give you an even number. And then you got even number plus 1. So this is one more than an even number. So it must be odd. Now here, 2 times any number is even. So this is even. Now n is odd. So 3 is odd. So this is odd here. And this is odd. And this is even. Because 2 times any number is even. But now you're adding everything. And these two odds together will give you an even number. So you'll have an even number plus an even number. So this thing here is even. Always. See, you can argue this thing out so nicely. Otherwise, you might want to try out, you'll test out, you put an even number here, put an odd number here, and so on. And you'll see it's true for maybe one case, but you don't know whether it's true for all cases. The way I'm proving it here, I'm just saying this is always even. I don't care what M is. And this one here is always odd. I don't care what N is, because the only thing I know is N is odd. So therefore, this product is odd. And this, of course, is odd. So this is, in all cases, regardless of what M and N are, as long as they are both odd, this will be even. Here you have even plus odd, so that's odd. An even plus an odd number is an odd number. Okay, so that takes care of that problem. Very, very important facts these are. The product and sum of even numbers and odd numbers. There's some very beautiful problems which have these applications. Hopefully we'll see some of them. Like look at this one here. Given two integers a and b, consider the number a b into a plus b. Can you determine if it's even or odd? Now, they just tell you that these two numbers are integers. We don't know whether they are odd or even. Nothing is said about a and b, but they're asking us to make a conclusion about this product. Right? So how do you do it? Okay. So let's take all the possible cases. Let's take the case where both are even. Or let's put it this way. At least one of A and B is even. Right. If at least one of them is even, so you'll have, if A is even, any even number times anything is even. Right. So if A is even, this is even. The product is even. And if B is even, for the same reason, then an even number times anything else is even. So or B even gives you that this quantity is even. Right, so the only thing is left now is we say at least one of them is even. So therefore we have to say both are odd. That's the other possibility. So again, it's logic. If at least one of them is even, if we've discounted with that, then what are we left with? It means that both of them must be odd, right? Because we can't have any of them even, so both of them are odd. So, but if both are odd, then A plus B is odd. The sum of odd numbers is even, I'm sorry. Because the sum of two odd numbers is even. So this part becomes even. And now once again, you have this product is even. So regardless of the parity of A and B, this product is always even, right? It's always even. Because one of them is always even. One of these products. So read. Okay, so that takes care of that. This product is always even. That's the conclusion. Why is my pen not working? Okay, a certain country has coins having values 1, 3, or 5 cents. So you got a 1 cent coin, make it slightly bigger, 3, bigger. This is 1 cent, 3 cent, 5 cents, right? So this country has got these 3 kinds of values. These days you don't have 1 cent. I'm not. Some of you probably don't even know what a 1 cent looks like. I don't think there is a 1 cent coin. The lowest coin you have is 10 cents. All right. When I was growing up, we even had half a cent. Now, can one make a change of 25 cent coin using all 10 coins, each having a value of 1, 3, or 5 cents? So now you got 10 coins. 3, 4, 5, 6, 7, 8, 9, 10. And these values, I've got them all in the same size, but their values can be 1 or 3 or 5. Now the question is, can one make a change of a 25 cent coin using this? So you might try to put, 2 5s and 2 3s. If you put 5, say suppose you got but you got 10 coins altogether. So you're going to get 10 numbers which add up to 25. So these 10 numbers add up to 25. And we're asking, is it possible? So this is a question mark. Can we get this possibility? Okay. So you think about it and say, well, suppose you can get it. Then I have an equation like this. As we said earlier on, that so suppose we can do it and see what happens. Now watch. They got 10 coins, right? So why don't I just pair them off into 5 groups? And I'm adding all these things, I'm not multiplying. anyhow, I can just add it to five groups. Then what do you have? You have all of them. Now look, all of them are odd, you see. That is an important fact. All these coins have an odd value. So these two will be even, you see, because they will be two odd. I don't care whether they are one or three or five, but they are sum of two odd numbers, and they'll be even. So this means that all these pairs are even, and you're adding five even numbers, and the answer will be even. Right? So if this is possible, then it means 25 is an even number, which is false. If possible, if it can be done, then 25 is an even number. And that's impossible. What we call contradiction. Contradiction means it's impossible. So the original assumption must have been wrong. Right? You make a If you make a wrong assumption, then you're going to lead to a false conclusion. So you got the original assumption. We said if it's possible, it's not possible. So the question is, can one make a change? No, one cannot. That's the answer. Because if you can make a change like that, then you can conclude that 25 is an even number, which is false. See, this is a very nice logic. Oh, I got a problem with my writing pad here now. I think my pen has given up. I've been using this nib for a couple of years now. So I think it's not working on anything. Oh, what am I going to do now? Well, all right, let's. Fortunately, I can't get to the next page. I'm sorry, I have a problem. I'm not sure how I'm going to handle this even later because I think there's something wrong with my writing pen. Okay, let's go on to question 5. How many integers are larger than this monstrous number? How do we read this? 20,242,013 multiplied by another monster, but smaller than the second number. You got a square number because they are both the same number. Now, if you multiply the first two numbers, I think a calculator might be able to do it, but might not give you the answer because you're going to have maybe a 16-digit number. And then you're going to subtract one 16-digit number from another 16-digit number. And you see how many numbers are bigger than this and smaller than that. So it looks like as if it's going to be very difficult to do it. Oh, okay, let me just get back to this. I think I got a problem here, guys. Hmm. Got this big number here. Okay. I'm going to say this again. I'm sorry about the delay. My pen doesn't seem to be working, but it seems to be working temporarily. Let's give a name to this big number here, right? And that's much easier to work with. So that is A. I'm going to give it the name A, and I'm going to call this the same thing, A. So this is A squared. Now this number here is so 20242013. If that is A, then this is 11 short of A. Because if you subtract 11 from this, you'll get to that. And the other number, 2035, is, you'll notice, it's 11 more than this. So that is A plus 11. So it means that the product of these two equals A minus 11 times A plus 11. Oh, but that's the difference of two squares. So that's A squared minus 121. Okay, so on the one hand, you've got A squared minus 121. If you put this in the number line, the top number, that number there, is smaller than A squared. And the second number is A squared, and that is sitting there, right? And you want to know how many numbers are there smaller than this. In other words, you're not allowed to count that. So smaller than this, but larger than this one here. So you want to know how many numbers are strictly between these two numbers. All right. Now, to that end, there's a very important fact that I need to share with you. I would have done this before, but I'm going to do it again. You see, if you got a set of numbers, consecutive numbers, let's call it x plus 1, x plus 2, and so on, up to y, all consecutive numbers. Then how many numbers have you got here altogether? Number of numbers. You can count 1, 2, 3, but you're learning about y, you don't even know what y is. So can you find a formula for this in terms of x and y? The answer is, you increase y by 1 and subtract the smallest one. You increase the largest one by 1 and subtract the smallest one. You might think that the answer is y minus x, because you want to know how many numbers there are altogether. That's not true. You can take y minus x if you like, but you must add 1 to it. Okay? So here, the smallest number here in this count here is A squared minus 120, because this is A squared minus 121. They are consecutive numbers. Right? These are all consecutive numbers. So this number here is 1 more than this. So if you add 1 to minus 121, you can get this. And here, the largest number is A squared minus 1. So there it is. You got the smallest number in these x's. You got the largest number. So the answer is, increase the largest number by 1, right? And subtract the smallest number. right? The smallest number is a squared minus 120. I'm sorry, it's a squared minus 120, right? The smallest number in these x's. Now here you'll have a squared, and this is minus a squared plus 120. So the answer is 120. Right? So the number of numbers in any consecutive set, this is very important. These are all consecutive numbers because I'm adding 1 each time. And how many numbers are there? We'll increase the last one by 1 and subtract the smallest one. The other way of doing it is you can decrease the smallest one by 1 and then subtract those two. You'll get the same answer. Okay? Or you could have counted this thing immediately. You could say, let me count from this way. A squared minus 1. This is a squared minus 1. The next one is a squared minus 2. Right? Next one, a squared minus 3. And we're going up to a squared minus 120. Now that is easy to count, but you have to count from backwards. So you have to be a little bit, ingenious. You say, let me count backwards. So you got a squared minus 1, a squared minus 2, a squared minus 3, and you're going to a squared minus 120, and therefore there are 120 numbers. Right? That's very much more elegant. That's a much more elegant way of counting it. Okay. All right, now let's just cross our fingers and hope that this thing works. It's not working, it's not working. All right, it seems to be, I'll have to fiddle around with this. The next problem is your homework problem. All right? Here, the homework problem is how many odd positive integers, the sum of whose digits is 4. So when you add the digits up, you get 4. So we don't know. That's the only fact that's given. And none of whose digits is 0. And how many of those are not prime? In other words, how many of those are composite numbers? Right? So that's your homework problem. Okay, good. This thing seems to have accepted. I'll have to use my mouse simultaneously with this. Right. I write down all the consecutive numbers from 25 to 208. 25, 26, 27. I write down all these numbers right up to 208. Right. Inclusive. So I'm writing 25 and 208. See, when you say between, sometimes it's not clear whether you're including the endpoints. When you say inclusive, it means you're including those numbers, not just the numbers between. How many digits have I written down in total? Well, I can see I got 1, 2, 3, 4, 5, 6. Now you keep going like this, and then suddenly you got 3-digit numbers. The 3-digit numbers start from 100. That's the first 3-digit number. And the last 2-digit number is 99. So you're adding 25, 2, 2, 2, 2 up to 99. And then you're adding 3, 3, 3, 3 up to 2008. So the question is, how many digits have you written altogether? Okay, now here you got 2 plus 2 plus 2 several times. But we need to know what the several is. In other words, how many numbers are there altogether here? These are consecutive numbers, and I've just told you how to do this thing, right? You got the smallest number, and you got the largest number. Increase the largest number by 1, and subtract the smallest number. 99 plus 1 is 100, minus 25 is 75. So you got 75 numbers here. Now, likewise, you got the three-digit numbers. We'll have to know how many three-digit numbers have you got. So it starts from 100 and it goes up to 208. Exactly the same thing. You increase the last number by 1 and subtract the smallest. So you got 209 minus 100, which gives you 109, right? So how many digits have you? Well, you have to multiply this by 2 because each one of them has got 2 digits. And you have to add all the digits in that lot. You got 109 numbers, and each of them have got 3 digits. So here you can actually count them like this. 75 times 2 is 150, and 109 times 3 is 327. And when you add these two, you get 477. So this problem here is it's not difficult, but you have to know how many numbers there are in a collection of consecutive numbers. I hope you never ever forget that all you have to do is to increase the last one by 1 and subtract the smallest. And you see how quickly you can start counting. Okay, so you're going to have other problems like this. Like this one here now. I'm struggling a bit here. Oh, there it is. Okay. Now the next problem is the sum of 2023 consecutive integers is 2023. Again, you got a problem on consecutive integers. Okay, and the question is, what is the largest integer in the sequence? Now here you have the sum of consecutive numbers. So that seems to be something which is important here. The sum of consecutive integers. So we don't know. So that's an interesting question. Suppose I got, say, 100 plus 101. These are all consecutive numbers going all the way up to 1,000. Is there any quick way of doing that? Okay. I'm going to give you a small lesson here now. Okay. And a couple of formulae. And you have to remember it. You see, consecutive numbers, the thing about consecutive numbers, I think I have done this thing before, but I'm going to do it again, is that you got what you call a sequence, a collection of numbers separated by commas, right? This is a sequence, they're consecutive numbers. But you'll notice that each one is obtained from the previous one by adding 1. Each number in this is obtained from the previous one by adding 1. Now, there's nothing special about 1. You can take each number and add it to each number is obtained from the previous one by adding something else, right? Need not be 1. Okay, sometimes there's something else is called, so there's a starting point. So the name given to the starting point is A. A, B, the first, what we call the first term. A is the first term. So these are all called terms. And this is the first term, second term, third term, last term, right? So often we use the symbol L for last term. Okay, so A is the first term. So the question is now, if you're adding 1 all the time, right, and the last term is 1,000, the question is, how many numbers have you got here altogether? See? Now, there is a important formula here. So let A be the first term, and suppose let D be the number that is added. Now, there's nothing special about added. You could have subtracted it. Right. To each, to get the next. To get the next term. Now, instead of saying added, subtracted, I could have, I simply have to say D can be negative, in which case you have A and you add a negative number, so you are subtracting D, okay? So you can just be we don't have to say added or subtracted. We can say added, but we allow D to be positive or negative. Right. So what happens here? Then you got your sequence becomes A plus D, A plus 2D, 2D, because you're adding this all the time. And it goes up to the last term. Right. Now, if there are n terms here, the symbol n is usually used to denote the number of terms in the sequence. So you'll see, if I had 2 terms, the last term is A plus D. If I had 3 terms, the last is A plus 2D. If you had 4 terms, the last is, this is 1, 2, 3, 4. If you had 4 terms, the last is A plus 3D. So the last, if I got n terms, it will be A plus, and you reduce the 3, reduce the coefficient by 1. So this is a very important formula. The last term is A plus n minus 1 times D. Okay? Where D is what you're adding, A is your first term, L is the last term, N is the number of terms. You've got 4 symbols here, but you must know what they mean. A is the first term, D is what you're adding all the time or subtracting, and N is the number of terms, that's the last term. So bearing all that in mind, well, actually, so that's the formula for the last term. Right. So just bear in mind that the last term is A plus n minus 1 times D. Now I'm going to try to rub these things out. And as I said, I've got a problem. I have a problem with this thing. Oh, good. Okay, so I'm going to rub this thing out. Hey, somehow this thing is limping its way through this session. At any time now, it might just give up. Sorry about this. And now, this is the last term. Then the other thing is, we can ask ourselves, if you add all these things, what do you get? So it's called the sum of n terms, right? So that's another question that is added. Okay, I'm not going to go into the detail with this, but just suppose I have, say, 100, and I got 104, and I got 108, and 112, and I got 116. Right. Now, suppose I add up all these. Now you can do it like this. You can say it's 100, 104, 108, 112, 116, and you can add up all these things, and you'll see it's 540. 12, 14, 20, 2 and 4, yeah. So you're 540. Now I got the answer very quickly. You might say, hey, this prof, you can add so quickly. I got a short way of doing it. What I did was I took this middle one and multiplied it by 5. Magic. You still get 540. Instead of adding all these, you take the middle one and multiply it by the number of terms you've got here. Now, what's the reason for that? The reason for that is, if you're adding all this, the middle one, the one just before that is 108 minus 4. That's not working. So it's 108 minus 4. The one before that is 108 minus 8, right? Because you are adding 4. So this if you go this way, 100 is 108 minus 8. And this way here, 112 is 108 plus 4. And this is 108 plus 8. So you're adding 4, subtracting 4. So when you add all these, the minus 4 and the plus 4 cancels, the minus 8 and the plus 8 cancels, and you're left with 5 108s, you see? And that's how you get this. Instead of adding all of them, you can simply take the middle term and multiply it by the number of terms that you've got. Okay. So that's a nice short way of adding these numbers. There are other formulae, and but I'm going to concentrate on just this particular one, which is a very nice one, because it'll help us to solve this particular problem. Okay. Okay, so let's try to solve this problem. Let's look at it again. The question says the sum of 2023 numbers is 2023. They are consecutive numbers. Okay, so let me see whether I can make some magic out of this. I'm struggling here to manipulate my mouse against the writing thing. Ah, it works. Okay, so you've got, we don't know what these numbers are, but they're consecutive. So we can think of them as a plus 1, a plus 2, and there are 2023 numbers. So if you got 2023 numbers, so the middle one, there's a middle one here, and this M is a middle. I need to have the middle one in this problem, and it goes all the way up to the last one, whatever the last one is, right? And when you add up the whole lot, you're going to get 2023. So you got, altogether you got 2023 numbers. When you add the whole lot, you're going to get 2023. But I just told you that the sum of all these numbers is the number of numbers multiplied by the middle number. Right? We saw 108 times 5. the year you got 2023, and that sum we are told is 2023, right? So therefore, you got this nice little thing here. So 2023 cancels magically. So the middle number in this is 1. That's the middle number, right? The question is, what is the largest integer in the sequence? So if this is the middle number, you got 2023 numbers altogether. So how many numbers have you got on both sides? You got 1 in the middle. So you remove that one. With the same number on both sides, because this is the middle number. And when you work out 2023 minus 1, you get 2022 divided by 2 is 1011. So you got 1011 numbers on the left, and you got 1011 numbers on the right. 1011 numbers. So if you are starting from 1, and there are 1011 numbers starting from 2 now, 2, you got 1011 altogether. The last one will be 1012. It will be 1011 plus 1. They're consecutive. So in this nice, pretty way, we've actually calculated the largest numbers integer in the sequence. The only thing we used was common sense, consecutive numbers, and what you mean by middle, and all that, and use this interesting formula that if you got a sequence where you're adding the same number all the time, then you can take the product, the sum of all the numbers is the middle number times the number of numbers. There's only one catch here. Sometimes you need not have a middle number. See? So what's the middle number? There's no middle number here. But if you really wanting to do that, what you could do is take the two middle numbers, take the average of the two. Just add those two and say that is the middle number, although it's not there. Take that and multiply it by the number of numbers. So here it's 4 plus 5. You take the average of the two, that should be the middle number. How many numbers have you got? 4 numbers. 4 plus 5, 9 number 2. 9 times 4 is 36. 18. 3 plus 4 is 7. 7 plus 12. 12 plus 6 is 18. So there it is. So instead of a middle number, you take the middle of the two middle numbers, right? Which is the average. So the largest number in the sequence is 1012. Very nice problem. But there is a small formula that you have to use to solve the problem. Okay, so I'll get on to the next problem. So far, I'm still surviving in some way or the other. Oh, okay, that worked. And then I have to manipulate. Oh, good, right. So the next problem is calculate the value of this thing. Again, you got a long, so many numbers here. And how do you work out the sum of all these numbers? So there's a lot of common sense here, guys. So here you got 2013 minus 2009 plus 2005 minus 2001. So now you got a plus minus and so on, and going up to 29 minus 25. Now this is not adding the same number. You're subtracting 4, adding. Oh, okay. You're subtracting 4 the first time, and then, but you're not subtracting 4 together next one. This is not minus 2005. You see? It's plus. So these things change, minus, plus, minus, plus. So how do you do this? Okay, well, certainly there's one thing which you can see immediately, that if you take any pair That is 4, you see. The next pair is 4. And the last pair is also 4. So you've got several pairs of numbers, and each one is 4. So the problem now is, how many pairs are there? If I know that, if I know the answer to that question, then I can simply take that and multiply it by 4, and I'll get my answer. Because it's 4 plus 4 plus 4, and we want to know how many pairs there are. Now that's, so how do you do that? Okay, so you have to know how many numbers there are altogether and divide by 2. Right? That'll give you the number of pairs. Equals number of numbers in that sequence divided by 2, because you're breaking it up into 2s. Now, how many numbers are there? Okay, let's kind of look from backwards. You got 25. Forget the signs now. I just want to count the numbers. 25, 29. It keeps going on like that. 2005, 2009, 2013. So I want to know how many numbers are there in this collection. If you read it backwards, and forget the sign, because I'm not interested in the plus or minus anymore. I just want to know how many numbers are there. Yeah. So if you list them backwards, it's easier to see, because now you can see it's increasing. Then you're adding 4 all the time. Now this, it rings into something that we said earlier on, right? You got the first term, so you got A. Okay, let me just put a I'm trying not to interfere with. It's working. All right, I want to count how many numbers there are here. And to do that, how many are there altogether? So we'll say it's n. Suppose there are n numbers. And we need to calculate n. Now we know this is something that we said earlier on. There is a first number, which is 25. There is a last number, which is 2013. And we know what we're adding, that is D, is 4. Right? Only thing is, what we don't know is n. And I told you there is a formula, L equals A plus n minus 1 times D. Earlier on, if you remember, we got this. So I can put these numbers here, 2013, that's your L. A is 25. Right? I got n minus 1 times D. D is 4. So 4 times n minus 1. So you got one equation with just that one unknown with n. And that's what we needed to find. N is the number of numbers, right? And you got an equation. So if you subtract 2013 minus 25, gives you 1988. Right? So anybody who was born in 1988, right? A 25-year-old guy, he would be 25 years old in 2013. Anyway, that's how. So this, if you subtract here, you get 4 into n minus 1. The 4 times n minus 1 is 1988. So n minus 1 is equal to 1988 divided by 4. 4 goes into that exactly, thankfully. And that's 497. So n minus 1 is 497. Sorry, all this is so messy here. N minus 1 is 497. So n is 498. So it's 498. So the answer is 4 plus 4 plus 4. We stopped short here. Right. Now remember, we had 498. So it's a number of numbers, number of pairs is the number of numbers. Now we just found out that it's 498. This is where we stopped earlier on, divided by 2. So that gives you 249. So there are 249 pairs, yeah? So the answer is each number is 4, and there are 249 of them. So it's 249 times 4, and that you can calculate is 996. So the answer to this problem here is 996. You see, you can solve all these problems with very little information. But you just have, in this case, I just use this one formula that L is A plus N minus 1 D times D. And the other formula, which I told you, is the middle number times the number of numbers is the sum. Right? You can get by quite a few problems with those two basic facts. But when you study this in high school, you study this. Oh, yes. By the way, these sequences are given a name. They are called, when I say the sequence where you got the same number added all the time, they are called arithmetic sequences. So if you go and look at your book anywhere, you can even Google arithmetic sequences. And there's a lot of information that you have on arithmetic sequences, but I've told you most of it. An arithmetic sequence is a sequence where you're adding the same quantity all the time to get the next one. Right? That quantity may be negative. So you could be subtracting the same quantity, which is the same as adding the negative number. Okay, so for arithmetic sequences, you've got the formula L is equal to A plus N minus 1 times D. And the sum of all the numbers is middle number times N, where M is a middle. And N is the number of terms. N always represents the number of terms. Okay, so that takes me to the next problem. Somehow limping my way through this. And now, God is being very kind to me because He's allowing this broken down pen to be functioning. Okay, I have a 3-digit number written as ABA with A and B different. All right, it's a 3-digit number. So you got the same number in the front, same number in the back, like 878 or 494 or 323, because you want, it's a 3-digit number with the first and the second, for the hundredth unit and the I don't know what you call this, the unit are the same, but the tens unit is B, but they are different now. So A and B are not the same. All right. Now, they say the 3-digit number is not divisible by 4, all right? And the sum of the 3 digits is 15. So you got, when you add the three digits, A plus B plus A, the sum of the digits, that is 15. So none of these are allowed, because here is 8, here it's 17, and here it's 23. So, so which 3-digit numbers are allowed here? So you got we can say A plus A is 2A plus B is 15. All right. So you got this thing about this three-digit number. The middle number is B. With the same number on either side. Now watch. You got an even number here plus B is an odd number. Now what we said earlier on, see how useful this is. An even number plus B is an odd number. Therefore, B can't be even. B is an odd number. Because 2 times this is even, you see. So in these equations, it's always nice to see 2 times A is a multiple of 2, or it's even. If I had 3A, it's a multiple of 3, right? Which means that if you add the digits, it's a multiple of 3. If it's 4 times A, then it's a multiple of 4. And you know rules for divisibility for such numbers. Anyway, this is an even number plus B is 15, so B is an odd number. So I got a 3-digit number where B is an odd number. So the middle number is either 1 or 3 or 5 or 7 or 9. See, so I only got 5 possibilities. But when you add the digits, you get 15. So what does it mean? 1 plus what gives you 15? It's 14. So these two numbers on either side will have to be 7. 3 plus what gives you 15? It's 12. So it has to be 6. 5 plus what gives you 15? It's 10. So these two are 5s. 7 plus 8 is 15. So those two are. And 9 plus 6 is 15. So you have that your number is one of these now. See how we brought it down? So this is one of the 3-digit numbers. But so are there 5 answers? Well, it is also said that it's not divisible by 4. And A and B are different. Now, you'll have to eliminate this one here because here, A and B are the same. You have to take that out. It's not divisible by 4. Now, are there any numbers here which are divisible by 4? Well, certainly, you have to allow for that because it's an odd number. It can't be divisible by 4. It's another odd number. And this one, you check to see divisible by 4 by only looking at the last 2 digits. When you divide this by 4, it doesn't go exactly, right? So that is also not divisible by 4, but this one is, because 36 is divisible by 4, so this have to be eliminated. I should put cross, right? Because it's not divisible by 4. Oh, wait a minute. I'm sorry. Yeah, those are ticks. You can't do that, but you allowed the other 3. Sorry, the mistake there. These other 3 were allowed because they are not divisible by 4. So there are only 3 numbers. How many different 3-digit numbers A, B, A are there? So they must answer the question. They're not asking you for the numbers are, but if it asks you for the numbers, you can write them down. 717, 474, 393. These are the only 3 numbers which are divisible by 3 and got the first digit and the last digit the same. And none of them is a multiple of 4. There are only 3 such numbers. Okay. All right, now we get on to the next problem, which is finished. There's no other. This is the last problem that I had. So somehow, although we started late, and I had some issues with my pen, which is behaving very well now. I don't know what happened. I think some of you guys must have been praying, but whatever it is, God certainly came in. Okay, now the usual is we've got 12 people here today. I must thank all of you for attending this session 6. We had for me, this was a very nice session because there are many things that I told you, the problems, if you tried them out on your own, you probably would have had difficulty in doing it. But you'll see how easy it is. See, problem solving is quite easy if you understand what the question is and try to go step by step into solving the problem using the information given, right? We didn't have much mathematics here, not many equations to solve or anything like that. Most of them were just logical. And today we spoke a lot about even numbers and odd numbers and the properties of even numbers and odd numbers. Okay, there are other many very interesting problems involving odd numbers and even numbers. And it's got very, very good applications, what you call parity. See? See, since I've got a little bit of time, I'll just talk about this for a short while. Like if you had two numbers, if a plus b over 2 is an integer, it means, what's the conclusion? Suppose a and b are integers, and a plus b over 2 is an integer. What does that mean? It means that a plus b is even. And so what does that mean? If two numbers a and b, when added, they're even, it means that both of them have got the same parity. Both of them are even, or both of them are odd, right? So the sum of two numbers is even only when they have the same parity. Very important fact. The sum of two numbers is even only if they have the same parity. That means both are even or both are odd. But if they have opposite parity, then the sum of the two numbers is odd. See? Now, I'll just quickly give you a sneak preview into something else. There's a very important equation in algebra. If you simplify AB plus A minus B over 2 all squared, let's work this thing out. It's AB plus, here, the numerator is squared, denominator is squared, so it becomes 4. Right, let's just go on here. So the common denominator is 4. This is AB over 1. So you'll have 4AB here. You're adding two fractions, and the common denominator is 4. 1 goes into 4 times. 4 times the numerator is 4AB. Plus, and here you have A minus B all squared. Now, what is A minus B all squared? Right? You should know what the square of a difference is. A squared minus 2AB plus B squared. Right? So, now if you simplify the numerator, you'll have, let's put the A squared in front. I got it in the front. 4AB minus 2AB is plus 2AB. I can group those together, plus B squared over 4. But now, A squared plus 2AB plus B squared is A plus B over 2 all squared. The numerator is A plus B all squared. The denominator is 2 squared. So when you add AB plus A minus B all squared, you're going to get A plus B over 2 all squared. So this is a very, very, very important equation. Don't ever forget this, that AB plus the difference, you take half the difference and square it, you will always get another square number, which is the sum of those two numbers, or if you like, the average of the two numbers. Because a plus b over 2 is the average. It's sometimes called the mean. The mean, the word mean is the same as average. So it's a square of the average is always equal to this. So there are two important results from this. And one of them is that you're adding a square to this. A square is always positive. So yeah, you got, we don't know about A, B. A and B are any two numbers. We don't know the negative or positive, whatever. But this thing is always positive. So you have to add a positive number to get to this, which means that AB, the product, is always less than or equal to A plus B over 2 all squared. It's a very, very important fact that the average, or if you want, you can take square roots. Square root of AB is less than or equal to A plus B over 2, if you take square roots on both sides. So it means that the average of two numbers is always greater than or equal to the square root of the product. Now that's a consequence of this, okay? I'm just mentioning this. It'll be nice to just remember this and think about it when you go home and remember this fact here. This is an important fact. The square root of the product, the square root of the product is always less than or equal to the mean or the average of the two. Now, the other interesting fact about this is that suppose I had a number like, suppose I give you a number, say 64. Let's make it easy. So, suppose I tell you, can you construct a right angle triangle having a side 7? Is it possible to construct a right angle triangle? All the sides must be whole numbers, 7, and you want to put something here, but it must be all whole numbers. Now, if you put 1 here, then you got square root of 7 squared plus 1 squared, 49 plus 1 is 50. And that doesn't work. So 1 is out. If you try 2, 7 squared plus 4 is 49 plus 4 is 53. That's out. So what can you put here so that the thing becomes a perfect square? Right? That is the question. That when you add these two, you're going to get a square number. Right. And what I just told you now is very, very useful to solve that problem. Now watch. Now I want to add 49 plus something equals a square. Oh, I'm sorry. Sorry, the other way around. I want to add 49 plus a square gives you another square. Right? So what square must I add? Now, according to this, all I have to do is AB must be equal to 49. I want the product of the two numbers to be 49. So which two numbers multiply to give you 49? Well, you can have A equals 1 and B equals 49. Those two numbers, if I choose A to be 1 and B to be 49, then AB is 49. Right. Then what must I add now? It's 49, A minus B. Or if you like, it's 1 minus 49, but you're squaring it. So you can say 1 minus 49 is minus 48. Divide by 2. That gives you minus 24. And when you square it, you get 24 plus negative 24 squared, the same as 24 squared. And that gives you 1 plus 49, A plus B, or the average of the two, is 50. And so the average of the two is 25. Right. Which means that I can construct to construct a right angle triangle having side 7, if this is 24, then I have 25. So I don't have to try 1, 2, 3, 4. It will take a long time. But this method here tells you can go straight to 24. All you have to do is to square this to get 49. Take two factors of 49, 49 and 1, and then subtract them and halve it. That's what you got. Subtract them and halve it, and you get your number. And that is how you construct right angle triangles. So you can construct any right angle triangle you can take, and you will see you can always, no matter what number you take, you can tell your teachers, I can construct a right angle triangle having side 241, 243, or whatever. They'll be quite shocked. How can you work out a right angle triangle having side 243? Then what you do is you square this by the calculator, right? And subtract 1, divide by 2, and that will be the other side. Okay, so it's a very useful thing to have. I thought I might just tell you these two things. One is that the square root of a product is always less than or equal to their average. And this other thing is how to construct a right angle triangle, which is a very, very important and useful thing. What I just told you now, very few people know, by the way, because even those people who write down solutions to Olympiad problems, they don't use this method. But I always use it. It's one of my pet discoveries. Okay, so that takes care of that. Okay, thank you very much for attending, guys. Some of you stayed till the end. I think all of you stayed till the end, which is very nice. You are about to go on holiday tomorrow, I think. So have a nice vacation. I'm not sure whether we are having classes next week.
No, bro. There will be no class.
Yeah. Now, Bafana, the point is a digit. You know what a digit is? By definition, digit is if I got 8, 7, 9, 3, 4, 6. This is a number. Its digits are this. You can't have negative numbers inside here. You don't have a number like 300 and minus 93. You know what I'm saying? So all these digits, they can be 0. It can start from 0, and it can go up to 9. But that's it. There are only 10 possible values for a digit. That's a very useful thing to know. All right. So I appreciate you asking this question because it emphasizes the fact that the only digits are from 0 to 9 and not negative. Okay. I don't know whether you were referring to digits, but you said negative digit numbers. I'm not sure which question you were referring to.
Sorry, sir, if I'm disturbing you, sir. But I was referring to question 13, sir. What if the whole number is negative, sir, not just the digit itself, sir?
Which question was that?
Number 13, the one that you're on, slide 11, sir.
Oh, this one, yeah, 3-digit number. This one.
Yes, sir.
Yeah.
If the whole number was negative, sir, would you still have the same answer or not?
Oh, I see. 3-digit number with A and B. Okay. So you are saying, like for instance, if I had minus 374 or 373, so if A is this number with A and B different, you see, when you the thing is, it's meaningless to speak about a 3-digit number or a 5-digit number with negative numbers, because in a case like this, if I say the first digit is 3, the second digit is 7, and the third digit is 3, right? You're not going to write down minus 373. You will write down 373. See? So whenever you're talking about a 5-digit number or a 2-digit number, it's a good question, but the number itself must always be positive. The digits are positive, and the numbers are positive when we're saying this. So, yeah, we didn't say integer. We said a 3-digit number. See, so it automatically means that the number is a positive number, which is an integer. It's a positive integer. See?
Okay, sir. Thank you so much, sir.
All right. No, it's a fair question, but it's actually, whenever you're talking about any of these problems, when you say think of a 3-digit number, you'll give them a positive number, right? Because you don't speak about a 3-digit number with negative numbers. It's only for positive numbers. All right. Okay. Thanks for that question. Are there any other questions? Again,